welcome to another live PEP class. Today being Monday, we're going to be doing our performance task, and our topic this evening is swimming pools for sale. So PEP students, you don't want to miss this one. Remember, your performance task is coming up. All your PEP exams are coming up, and you want to be prepared for all of them. So I'm going to play for you now the schedule of classes so that you'll know which days, on which days we do what. We have live PEP classes every week. Also, we have 5 CSEC classes every week as well. So here's the dates, write down the times, and what is done in each session. CSEC math students, I know you are busy preparing for your math tests, the CSEC exams coming up. I have a very important question to ask you. Do you like my hat? Thank you. No, another important question. A math problem wrong simply because of making one mistake. I'm sure you have, as thousands of other students have. Now in this series, we're going to be looking at the common mistakes that students make with all the topics in math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, it's absolutely true, and we're going to be looking at the common errors that students make in the different topics, and we can certainly avoid making them. Are you ready? Come on, take my hand. All right, scholars, so we are ready, and I want to welcome everybody who is joining us. If you're just on Facebook, on Twitter, on YouTube, everybody in the chat, welcome. And Diana is starting things off by saying, I love mathematics, and we all do. We all love mathematics. It's a wonderful subject. So I share your opinion, Diana. I share your passion for mathematics. As usual, I want to invite my studio crew to join me, and they're going to help me figure out this performance task this evening. Okay. Welcome, Antoine. Welcome, Jer. Welcome, John, Amari. Listen, my studio crew, my faithful, loyal, brilliant studio crew. So now we're going to share our screen and go right into the performance task. Welcome, Ashanti. Welcome, my love. Here we go. All right. The title of this performance task is Swimming Pools for Sale. All right, so waiting for it to come up on the screen. Get your books out, get your pencils out. And are you seeing it right? Scholars?
Yes, miss. Yes, miss.
Okay. So swimming pools for sale. Madison, please read.
The board of Lewiston Primary School has decided to construct a swimming pool on the school grounds. There is a 120-meter squared plot of land available for the swimming pool and changing area. The swimming pool will occupy 3/4 of the space.
Again, please.
The board of Lewiston Primary School has decided to construct a swimming pool on the school grounds. There is a 120-meter squared plot of land available for the swimming pool and changing area. The swimming pool will occupy 3/4 of the space.
Okay, thank you, ma'am. Antoine, please read question 1.
Yes, miss. Question 1. If the swimming pool will be a rectangular one, write 6 possible dimensions for the length and the width that will occupy the total space in
On
available
the on the ground.
on the ground. Remember to include the units. Question 1. If the swimming pool will be a rectangular one, write a possible dimensions.
Six possible.
Yes, write 6 possible dimensions for the length and the width that will occupy the total space available on the ground. Remember to include the units.
All right, scholars. So that's the first task. We want to find 6 possible dimensions for the that they will occupy on the ground. Welcome, Adiana. Good night. Welcome. So we want to know 6 possible dimensions for the length and the width. So remember, in the PEP, you might have some open-ended questions and some questions that they don't have fixed answers, or maybe they have a set of fixed answers, a set of possible answers. This is one such. Some persons will choose a different width than others. Same square meter for the area. Some answers coming in. Madison saying 12 times 10. Amari
No, miss, I
and John
haven't
are
said
saying 12
anything.
times. Hold on. Isn't it? Oh, sorry. I'm reading the wrong name. Okay, so Amari and John, 12 times 10. Aiden, 12 times 10. Amari, 6 times 20. Madison times 8. 10 times 8. So, why is it 10 times 8, Madison? That is 80.
Miss, I'm just realizing that it actually has to occupy all of the space.
What has to occupy all of the space?
The
Amari is
pool.
saying times 30. Does it say that the pool should occupy the entire space? Did it say that?
No, miss, it said
Let's go
one.
back.
No.
Let's go back. Said
1/3.
the swimming pool will occupy 3/4 of space.
Yes, miss, 3/4.
The swimming pool will occupy 3/4 of the space. So the swimming pool will not take up the full 120 meters square round. What space will the swimming pool take up on ground? You realize colors, those
90.
that you've been giving me so far, right? It should add it should give an area of 90 meters square. Ashanti wants to know if she can join the live in studio, I'm assuming. I'm going to post the link if you want to join me in studio. However, you have to come very early because there's a limit. As you can see usually on the screen, there's a limit of four scholars are allowed. So the first 4 are selected by the system. There's a link, and tomorrow if you come very early. But I have some scholars who are very early. So Ashanti, you'd have to come extra early to get in. So students, we're saying on the ground, the pool should take up 90 meters square, not 120. Remember, it will be the pool area that will space. So the pool will only take up 3/4. And 3/4, so let's see if it works. So we had to find 3/4 of the 120. So it's not the full 120. So 3/4. So 3/4 times 120. And well, we can put 120 over 1 as well as we can just leave it. 4 into 4, 1 into 120, 30. And 3 times 30, that's 90. And remember, area, so it's going to be in square units. So we know the swimming pool will take up 9 meters. Question. Amari, can you read questions?
Okay, miss. Number 2. On the grid provided, draw and label the available space and the design of the swimming pool that you will choose. Remember to include the units. Number 2. On the grid provided, draw and label the available space and design of the swimming pool that you would choose. Remember to include the units.
So this is our grid. And based on the dimension you chose, so we had to come up with, we're asked to come up with 6 possible dimensions for the length and width. So Amari said 10 times 90. But remember, Amari, the full area on the ground that the swimming pool will take up is 90 meters squared. So it can't be 10 times 90. That won't give 90. That will give 190 meters squared.
The dimension that I have
18.5. Remember, these should be in meters times meters.
Yes, miss.
What? Say that again, John.
Miss, it was Amari, miss. I was saying I didn't answer that. Miss, I didn't put 1090. It was done.
Okay, I was trying to explain something. The word.
Okay, but you see, it always comes up as Amari and John, so I can't tell who is doing what.
Yes, miss.
So I have to just read the name that I see. I always see Amari and John, right? I don't know if there's a way you can separate the link, the post. I don't know. I can only read what I see. Just write the name of the person, answer each time. So we have
Miss,
18 times 80 meters times 5 year. Yes, Aaron?
a person that mentioned that I have is 10 times 9. 10 times 9.
10 what times 9
10
what?
meters times 9 meters.
10 meters times 9 meters. Okay. And Jira has 18 meters times 5 meters. Any other possibilities to get our 90 meters squared? We have 15 times something. What would give 90?
Miss 15 times. Sorry. Oh yes, Miss 15 times 5. Miss 15 times. No.
15 times 5
No worries,
would give
Miss.
90.
No.
Are you
No.
sure?
No, Miss.
15 times what?
Miss, it's 15 times 6.
15 times 6. Okay. It's how about 3? Could we have
Miss
3 times
30.
something?
Yes, Miss, 3 times 30.
3 times, so 3 meters times 30 meters. How about, suppose we could have some decimals, it doesn't have to be fixed. That is more tedious work with the decimals. All right, 6, 18 times 5, 10 times 9 is 30. How about 8? Can 8 go? We would get a decimal, but that's allowed. How many times does 8 go into 90?
Miss, if it goes into 90, 11.5.
11.5 or 11 and a
Okay.
quarter. We can do that, that is allowed. You can have decimal or fractions once they multiply together. So, okay, so let's move on. So on the grid we are to put our so this is so let's say we need a complete. The instruction says we are to draw and label the available space and the available space and the swimming pool, the space for the swimming pool. So we can just draw the space. It needs to be 120. The full available space needs to be 120. And then, so here we have the grid, which has, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, All right, so on the top, we can use a scale of, let me see, 15. The dimensions that I'm going to choose for my grid, I'm going to work with 15 by 6. All right, so I need to draw one, two, three, four, five, 6, 7, 8, 9. All right, so 15 by 6. And each grid is 9. So that's 1, 2, 3. If I want this to be 15 and I have 9 spaces, I'm trying to work out the scale that I need to make it so that it's even. All right, so look at the spaces, guys, and tell me what would you recommend that each space be along the horizontal and along the vertical. We want to figure out a unit. I'm using the 15 by 6 to get the full 120. So what can we make each space be in order to get 15 here? Let me hear some suggestions on how we can work out a scale for the grid. 5 meters. That means we'd only use up 3 spaces, but that's not going to be wide enough to use.
Three, miss.
All right, let's use 3. And I'm using 15. Need 1, 2. So let each set 1 unit. My mouse isn't working. So 1 unit horizontally would be equal to 3 meters, right? So that means for the 15, we'd need 1, 2, 3, 4, 5. Okay.
This is
So we
kind of
have,
like the timetable.
that's 15 meters. Say that again, John.
Miss, I was saying it's kind of like the timetables, miss, because 5 times 3 is 15.
Right. Okay. And along the, and this is horizontally, right? So we'll just put that for horizontally. Along the vertical scale, we can let 1 unit be 1 unit be 2. All right, so that would mean I would need 3 units there. And I would have 6 meters. 15 by 6. All right, and the to be 90. So here we are. So this is the 15 by 6. This is the pool. All right, so for the total space now, so we need it to be 120. All right, so that's 3, 3, 6, 9, 12, 15. So let's use the 12 by 10 for this one. So to get the 12 up here, let's see, 20. All right, so we need one more to make 120 here. And then the 6 would be there. All right, so the total area here would be the available space, which would be 120, the 18, and then this area here, the 15 by 6 meters would be the pool. All right, so let's double check and make sure we have the units properly. All right, so 15 by 6, that's 90, that's for the pool. All right, so Madison,
Miss?
read question 3 for me, please.
Question 3. The changing area. The changing area will occupy a half of the remaining area. How large will the changing area be? Number 3. The changing area. The changing area will occupy a half of the remaining area. How large will the changing area be?
All right, so remember the full area is 120 meters squared, and the swimming pool is occupying 90 meters square of that. So first of all, what would be the area left back for the changing area? And then I want you to tell, the next question will want you to tell the dimensions. So how large will the changing area be?
I would say since the pool takes up 90, you would have to find the half of 90, which would be 30.
Is it a half of 90? Did it
Yes, miss?
say half?
No, miss. Well, yes, miss. It says the changing area will occupy a half of the remaining area.
Okay, so first of all, what is the remaining area?
90?
No, 90 meters squared is for the swimming pool.
Yes, miss. I thought I got mixed
90
up.
meters squared swimming pool. So the total that's available is 120 squared. So if 90 meters squared is for the swimming pool, what area after you take out the swimming pool? Half that will be for the changing area. All right, so Madison is saying 45. Sorry, Jerry
No,
is
Miss,
saying
that's
45.
not me.
Sorry, I corrected myself. I don't know why I keep calling Madison. So Jerry is saying 45. And since you're leaving out your units, and these are very important. So follow me now. 120 meters square was the total available space. 3/4 of that is for the swimming pool. So when we worked 3/4 of that, we got the 90 meters square. Now the changing area will occupy half of remaining space. So what is the remaining space? First of all, 120 meters square was total available space. Called the 90 meters square, which is for swimming pool. So what's left back is 30 meters. And the changing area will occupy half of this space. So the changing area will occupy half of 30. So
Yes,
what is
Miss.
half
The half
of 30?
30 is 15 meters.
Which is what? The changing area will occupy 15 meters square. John, can you read question 4, please?
Okay, Miss. Number 4, the changing area. Write the dimensions of length and width that you think the changing area would be. Number 4, the changing area. Write the dimensions of length and width that you think the changing area would be.
So it's worked out that the changing area is the squared. So what are the dimensions of length and width that you think the changing area would be?
Miss,
I'm not seeing any unit coming in.
a dimension could be 5. A dimension could be 3 meters times 5 meters.
Okay, so Antoine is saying 3 meters times 5 meters. Madison is saying the same thing. And those would be the logical guess. Another guess would be 50 meters times 1 meter, but that's not convenient space. It's possible, but it's not a convenient space. So the most practical space would be the 15 meters by 3 meters. Sorry, the 5 meters, sorry. 5 meters by 3 meters. And that would give us the full 15 meters squared that the change area will occupy. Question 5.
Okay, Miss. Okay, Miss. Let's dive in. The swimming pool will be uniformly deep. There should be half a meter of space between the top of the water and the top of the pool. If the total volume of space inside the pool will be 360 meters cubed, what will be the height of the water? Let's dive in. The swimming pool will be uniformly deep. There should be a half a meter of space between the top of the water and the top of the pool. If the total volume of space inside the pool will be 360 meters cubed, what will be the height of the water?
All right, so how are we going to approach this question? What will be the height of the water in the 358.5 meters Miss Madison, how did you get that?
Miss, that it's 359.5 meter cubed, and I just minus 0.5 from
355. You get that?
I minus 0.5 from 360
Why?
because it says it should the space on top of the pool from the water should be 0.5 meters away from the top. Miss, I think I
All right.
muted before I finished.
Okay, so number 6 says draw and label a diagram of the pool with the water in it. So let's do that and then go back to that question. So it says that the pool is uniformly deep, means there's no deep end and shallow really. All along the base of the pool is the same depth. All right, so if this is our pool, and it is filled with water. So the base of, they said that the volume of space inside the pool will be 360 meters cubed. And then there will be half a meter of space between the top of the water and the top of the pool. So the volume of space that the water will take up, so the water will come up to a certain height, and then there should be a half meter between the top of the and the top of the pool. This here is 1 meter. The base of the pool, or the volume of space within the meters cubed. So do you remember the space? Do you remember the space at the bottom of the pool? The area that the bottom of the pool is taking up. Do you remember that?
8
Yes, Miss
15.
90. Yeah.
So let's go back to that question. Let me see. No, that's for the changing area. All right, so this is the question. Remember,
Yes, Miss
the
90.
it's a rectangle along the pool, the base of the pool on the ground, the area 90 meters. So if the area of the bottom of the pool is 90 meters, and the total area that the water will, total area of space in the pool that the water occupy is 6 meters cubed, what will be the height of the water? Remember, volume is area times height. So if we know the volume of space that the water is going to take up, and we know the area of the base of the pool, and I should add the volume of space that the water will occupy. So it's the space that the water will occupy when you put the water in. If volume is area times height, and we know the volume and we know the area, how do we find the height? Think about it. If volume is area times height, we know the volume, we know the area. How do we find where the water will reach? So let's write that. So we're in volume is a rectangular space, so it's a cuboid. The volume is the area times the height. You know the volume that the water will take up is 360 meters cubed. Squared. 90 meters square. So how would we volume area times height? How do we find the height? We divide the volume by the area. So the height would be
Yes.
360 meters. Divided by the area, which is 90 meters squared. And 90 goes into 360 4 times. So the height is 4 meters. There should be a half a meter above the water up to the top of the pool. So the full height of the pool then would be we would have the 4 meters up to where the ones, and then we'll have 0.5 meters or half a meter between the top of the water will end and the top of the pool. Here, remember the base was 90 meters cubed, and my dimensions were 15 meters by 6. 15 meters by 6 meters. That's our 90 meters cubed for the base pool, the area of the base of the pool, and then these dimensions here for the height, 4 meters from the base to where the water is going to end, and then from where the water ends to the top of the pool is 0.5 meters. So in all this height will be 4.5 meters. All right, down the dimensions, we're going to need them a little on. Probably, maybe. All right, who hasn't read as yet? Who hasn't read? Everybody has read? I'm not seeing John and
Yes,
Amari.
miss.
Yes.
Miss,
Yes.
All
Miss
right, back
Amar
to
is
you,
backstage.
Antoine. Oh,
Miss Amar is backstage. Yes, miss. Okay.
okay, John, go ahead and read
Okay, miss.
number 7.
Number 7. Swimming pools for sale. Blue Hole Construction Company makes custom swimming pools. The cost for each meter cube of pool space is for right there. Miss $45. What will be the cost of constructing the pool? Number 7. Swimming pools for sale. Blue Hole Construction Company makes custom swimming pools. The cost for each meter cube of pool space is $45. What will be the cost of constructing the pool?
All right. So how are we going to work that? Any ideas? $45 per meter cube of pool space.
Miss, would you have?
How are we going to work out what is going to cost?
Miss, I would say that we should multiply it.
Huh?
I would say that we should
Say again,
multiply.
Antoine.
I would say we should multiply it.
Speak up.
I would say we should
Multiply
multiply
what?
it. Miss 45
What?
and Miss 45 and 1 meter squared.
What's the volume of space inside the pool? Let's go back to the
360.
diagram we just got.
Miss, I put an answer in the
Wrong.
chat.
So let's go back to.
Miss?
Okay, let me hold on. So tell me how you got that, Madison.
All I did
16,200.
Multiply 360 by 45 because the dimensions of the pool was 360 meters
Yes,
cubed.
Miss. That's yes, Miss. Let me work it out for
The
myself.
Okay, the dimensions of the pool was 360. Is that what it said?
Meters
It
cubed.
said enough space inside the pool that the water will occupy is 360 meters cubed. But remember, there's a space inside the pool above the water. Remember?
Yes, miss. So I would have
The
to add that.
360 meters will be up to here, up to here. But this is really 4.5 meters. So the volume of space in the entire pool would be the 90 meters on the ground times 4.5. The height all the way up to there. See? So volume is area of the base times the height for the total space inside. Because remember, they are constructing the pool. They're not just making the part of the pool where the water is going to reach up to. They have to think about the entire space that the pool will take up because they are building the entire pool. So it will be the 90 meters on the ground times 4.5 meters. How much does that give? Let's work that out. All right, so let's work that out. So it's 90 times 4.5. 5 times 0 is 0, 5 9 45, 4 0 9 is 36, 0 1 8 810. And we need to put in where did I go wrong? I added something wrong. 500 5 9 is 45. Oh, this is a 0. 400. All right, let me do that over. So we have 4 times, so we hold our space, 4 0 0 4 9 is 36. Am I writing the wrong thing? 4 9 is 36. And we would add to get 0 5 0 4. Decimal place, so it's 405. So 405 cubed That's the entire space that the swimming pool will take. And it's $4 per meters cubed. So when we multiply it by the 4.5, we got 405 meters. Now we need to multiply that by dollars per meters cubed of space. That's what it's going to cost to connect the pool. All right, so 5 5s, 25, 5 times 0 is 0 plus 2, and 5 4s, 20. 20, 4 0 0 plus 2, and 4 4 16. So we have 5, 2, 2, 8. 18,220 dollars. 18,220. Any questions on this one? Let me know. All right, so everybody's good. So let's move on.
Yes, miss.
Listen, question 8, please.
Question 8. Take something off. The school will be given a discount of 15%. How much will the school board have to pay in total for the construction of the swimming pool? Number 8. Take something off. The school will be giving a discount of 15%. How much will the school board have to pay in total for the construction of the swimming pool?
All right, so we need to find 15% of the 18,225. So 18,225 times 15 over 100, which is 0.15. So 15 divided by 100 would give 0.15. And when we multiply this number by 0.15, we would get $2,733.75. So this is 15% of this number. 15% is 15 over 100. 2 places back, so 1, 2, so it is the same as 0.15. So the 1,225, and we need to subtract that now. It's a discount, so we need to subtract. So 18,225 minus 2,130.75. We have to fill placeholder. So we'd end up with 2, 1, 9, 4, 5. All right, so that's $15,491. Let me write it here. $15,491.25.
And 25 cents. Yes, ma'am.
Board will pay after the 15% discount. Question 9,
Yes, ma'am.
Jer, question 9.
Okay, Miss. 14. A tanker will take 3 hours to fill the swimming pool halfway with water. How long will it take to fill it 1/10 of the way? A tanker will take 3 hours to fill the swimming pool halfway with water. How long will it take to fill it 1/10 of the way?
All right, so watch this question. 3 hours to fill it way. How long to fill it 1/10 of the way? The time will take 3 hours to fill it halfway. How long will it take to fill it 1/10 of the way? How will we approach this? If it takes 3 hours to fill it halfway, how long will it take to fill it all the way? At the same rate. Okay, so Madison says 6 hours. All right, so we can start there. Antoine says 6 hours. So 3 hours to fill it, 6 hours to fill it all the way. So if it's 6 hours to fill it all the way, how long will it take to fill it 1/10 of the way? Six hours to fill it all the way. How long to fill it 1/10 of the way? So Madison says 12 minutes. Did you get 12 minutes?
Miss, I found 1/10 of 6, and I got 6/10. So I multiplied 6/10 by 60/1, and I got 12.
And you got 12? 6/10
Yes,
times 60/1, and you got 12. Double check.
yes.
6/10 times 60/1. I think you'd get 12 for that. Anybody else? Any ideas? So the
Miss, would you get
6 hours to put all the way. Yes, Antoine?
you would get 36?
Go ahead. You get
Miss,
36.
6/10 times
Yes, you'd get
60/100
36.
is 36.
That would give 36, not 12. So what we can do is change the 6 hours to minutes,
Which
which
will
is
give
300.
60.
and then divide
Yes,
by
miss.
10. Or you can do it the way Madison, she just found 1/10. She expressed one, so she put 6/10 hours times 60. Or you can change the minutes 360 and find 1/10 of that. We have 2 questions to go. All right, so the working out for this one. So we said 3 hours is halfway. So we know half times 12. So 6 hours would be for the full. And we'll find hours. But remember, 6 hours is 6 times 60. 60 minutes make an hour. In terms of, we divide that by 10. So it's 6 minutes. Next question, and then what? So I'll read this one, number 10, swimming lessons. The school will offer swimming lessons to outsiders on Saturdays. There will be 3 90-minute sessions starting at 8:15 a.m. with 10-minute breaks in between the sessions. At what time will the last session end? Number 10, swimming lessons. The school will offer swimming lessons to outsiders on Saturdays. There will be 3 90-minute sessions starting at 8:15 a.m. with 10-minute breaks in between the sessions. At what time will the last lesson end?
Miss, what time will it end? Okay. Miss, do I have to
What time
use
will
the...
the last lesson end?
Oh, okay, miss. The 1:30, like... 30 minutes that will go from 8:15 to 9:45 plus one more plus one more.
So it's 3 90-minute sessions. How long is that in all?
Miss, that's 4 hours 30 minutes.
Okay, so 30 minutes. And how many 10-minute breaks will there be?
Miss, there'll be 1 10-minute break. Miss, 1 10-minute break.
There's a 10-minute break in between sessions. So between the first and the second, you have between the third, you have a break.
So that's
So there
two.
will be 2 10-minute breaks, 20 minutes,
Okay, miss.
minutes to the 3 hours and what we said, 3 hours 40 minutes.
No, miss, it's 4. Miss, 4 hours 30 minutes.
4 hours and minutes, we said.
Okay. Yes, miss.
So
No,
in
miss, no.
all, it's 4 hours and right?
Yes, miss.
4 hours. Okay.
Yes.
So add that to the 8:15.
Okay, miss.
Hours and 50 minutes to 8:15.
Yes, miss. Okay, miss. You'll finish at
90,
1:05. This is finish at 1:05.
1, 5 a.m. or p.m.
Miss, PM.
1:05 p.m. So 3 times 90, that's 100 and 270 minutes. 2 10-minute breaks. 20 minutes.
Were you always scared of swimming?
So is 290 minutes,
At first, I was kind of excited. At the same time, scared. But then,
which is 4 hours and 50 minutes. So we're going to add 4 hours minutes to 8:15. And we're going with, when we add the minutes, we get 6. Can't leave the 65 there. We take out 60 from it, and we're left with 5. And we carry that 1 hour, 19 and 4. So that will bring us down to 8 and 4, 12, 1 o'clock. So that's 1:05 p.m. And the last question. All right, so Jira, I want you to read this question for me.
Okay, Miss. The school will offer swimming lessons to outsiders
No,
on
Jira.
Saturdays.
Question 11.
Oh, 11. Jennifer plans to sign up
Question
for 2
11.
sessions each Saturday. She will swim every Saturday. If each session is priced at $250, how much money will Jennifer pay for 7 weeks? Jennifer plans to sign up for 2 sessions each Saturday. She will swim every Saturday. If each session is priced at $250, how much money will Jennifer pay for 7?
Okay, what's your answers for that one, or tell me? 250 per session. She
1,750.
plans to do each Saturday. Okay, so Madison says $3,500. Let me see your answer meaning. I need to tell me you got that answer. When I call on you, you need to know how you got that answer. Or Jer 35. Tell me how you got it, Jer.
Miss, if she did the lessons for 7 weeks and she did 2 sessions for 7 weeks, that means it's gonna be 14 sessions. So I timed 14 sessions by the price for one session, which is 250, which gave me 3,500.
Or Madison, how did you work it? Oh, Madison isn't there. Antoine, you got 750. Tell me how you got it.
Oh, miss, not 1,750 is not my final answer. My final answer is 3,500. How I got it,
Tell me
miss?
how you got it.
First, I multiplied 250. 250 times 7 will give you 1,750. And then times 1,750 by 2. Since Jennifer plans to sign up for 2 sessions each Saturday. So when I times it by 2, I get $3,500.
Okay. Madison, how did you get your answer?
Miss, first I multiplied 250 by 2 and I got 500, and then I multiplied it by 7.
All right. So all 3 scholars, they got the same answer, but each one multiplied different things first. So one person multiplied the 500, the 250 by 2, then by 7, and one multiplied the 250 by 7, then by 2, and one multiplied the 2 by 7, and then the 250. So either way, you're going to put the same answer. You just need to understand you need to multiply it how many tons per day times how many days, tons per week. So each Saturday is 1 week is only on Saturdays. How many weeks times the cost per. All right, and that's it for our performance task for tonight. Remember, we have another performance task on Wednesday, so make sure you join us for that. And don't forget, we have 5 live PEP classes every week. I'm about to play the schedule for you now so you can be reminded of which days and which times. We have our PEP classes as well as our CSEC math. We have 6 live CSEC math classes every week. So until tomorrow, scholars, take care, have a good night, have some rest, and I'll see you same time, same place tomorrow.
See you, miss.
See you tomorrow, guys. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC. At the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, that's absolutely true, and we're going to be looking at the common errors students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.